Okay, so very function. Negative x. Then we get sine of negative x. I'm going to change this to the power of 1 over 3. That's the same as sine of, in the input, this right here is equivalent to minus x to the power of 1 over 3. Okay, so we have sine of a negative of an input. So that's the same as, because sine is an odd function itself, that's equal to this. Okay, which is equal to f at x, negative of f at x. So this demonstrates that, or proves that, it's an odd function. If it's an odd function, okay, so this right here is going to equal to this by integral properties. This is true for all functions, provided it's continuous in the interval. But because it's an odd function, this right here, right, is equal to 0. Okay. So clearly we can say that this is greater than or equal to 0. Okay, because this is 0 plus 2 to 3. Now, sine, let's visualize sine. Okay, so this is pi, right? So that's 3.14. So okay, so let's say it's 1, this is 2, 3.14, just past this. So visually you can see that that's going to be, the positive area is going to be larger than the negative area. So from this picture you can see that this right here from 2 to 3 is going to be, okay, first of all, integration from 2 to pi, okay, 2 to pi, and then we add pi, okay, pi to 3. This is negative, this is positive, okay. But, okay, so this length here is 3 minus pi, okay. So so that right there, by symmetry, so this is 3 minus pi, which is essentially 0.14, roughly 0.14. So if you go this way, 0.14, this area and this area will be the same. So that's what I'm going to do here. This location right here is pi minus the difference between 3 minus pi. Right? So it's going to be 2 pi minus 3. So we're going to integrate from 2 to 2 pi minus 3. Okay, I'm just going to write f at x here. I don't want to write this long expression over and over again. And then 2 pi minus 3 to pi. And from pi to 3. Okay, so these two have the same and opposite area, so that's going to cancel out. Okay, and this is strictly a positive area. So that's why we can really say this is greater than or equal to, okay, this, greater than or equal to 0, because this is always a positive area. I guess we can say as a side here, since f at x is greater than 0. Right? From 2 to 2 pi minus 3, the function itself is above the x-axis. So we can say the integral is greater than or equal to 0. Lastly, we have to show that it's less than or equal to 1. Well, let's go back to here. Okay. So that's, right, that's an interval length of 1. So 2 to 3 is 1. So let's just say 2 to 3, 2 to 3. And sine of any angle, the maximum height is 1. Okay. So the maximum area that you can achieve is 1 by 1. Right? And that's why. So we can say since, right? And since 2 to 3 for sine of really any function, right, is less than or equal to 1. And therefore, we can say this original expression here, okay, sine of